Hi guys, welcome to Tech Geek. So today we are back with another Leetcode question. That's the daily Leetcode problem. Basically, I try to discuss each and every Leetcode problem with you all and give the best of approach that's helpful as well as easy to understand even for the beginners. Before beginning, I'd like to request you all to please like, share, and subscribe. And in case you have any queries regarding any subject, interviews, questions, or any OA rounds, or anything, please let me know. I'll be there to help you out with the preparation as well as the experience. So, the question for today was partitioning into minimum number of deci-binary numbers. Okay, that's a deci-binary number. It was a Leetcode medium question. So basically, it's rating. If you ask me how it should be around 3 by 5. Okay, so if you know how to go for it. It's quite easy. Let's see what the question asks. The question says we have a decimal number. Okay, it's called deci-binary if each of its digit is either 0 or 1. So in short, okay, first let me read, then I'll give you a hint. Okay, without any leading zeros, for example 101 and 1100 are deci-binary numbers, while 112 and 3001 are not. So any deci-binary number, they'll just have 0 or 1 without having any leading numbers. Okay, given a string n represents positive decimal integers. So we are working on positive decimal integers first of all. Then return the minimum number of positive binary numbers needed so that they can sum up to n. So let's say we have been given this number. We have to find all the sort of positive deci-binary numbers that sum up to this number. Okay, like 10 plus 11 plus 11. Now why they are deci-binary? Because they are just made up of zeros and ones. Okay, let's see now. Okay, I have taken this example. We have 154 and 300. Now, first of all, the basic concept is you should know what is a deci-binary number. That's the basic thing, right? So, if you know the deci-binary number, you will be like, this was such an easy question, right? So, let's take for 1. Okay. For 1, the deci-binary representation is just 1. For 2, we have 2. For 3, we have 3. Then coming to 4, we have 4. So I hope you guys can see one thing. The number of ones is equals to the number. That's the digit actually, not the number. So if you know this concept, I guess it's easy to form any deci-binary number, right? Now coming to the fact, these were single digit numbers. And we have to find the deci-binary numbers that sum up to this number. So we have a condition here. Now what we'll do, let's take this example itself. Okay, let's clear this screen first. We'll take this example. That's 154. Okay. Now what we'll do with 154, the very first thing is we'll find the deci-binary number for each of the digits. So that is 1, 5 and 4. And what is the deci-binary number here? It is the maximum. So maximum is 5, right? So what we'll do is write 5. Why I'm writing the largest number? Because for the others the leading should be 0. Sorry, not leading. The ending should be 0 because in deci-binary the leading is always 1. Again for 1, so this is 1. So the rest of the digits should be 0. Keep that in mind that for rest it should be 0. Okay. Again, that's 4. 1, 2, 3 and 4. Again, the rest of the digits, so here there was just one digit, this should be 0. Now coming to the fact how to sum this up. I don't think like this, if you sum up this will give you any sort of number that's 154. No. What we need to do is we need to group them in this way. Okay. So first number should be 1 1 1 plus, coming to the next row, next column, so 0 1 1, again 0 1 1 plus, again 0 1 1 plus 0 1 c. Okay, now add this up and check. 1 plus 1 2 3 4. Okay, let's take the middle ones. 1 1 1 1 1 5. The first one, that's 1, so this sums up to 154. How many numbers were there? 5. Now let's take another example. I'll tell you one trick too, so that you won't be required to even find this up now. We had an example of 32. Let's see the same. Okay, for 3 it's 1 1 1. For 2 it's just 1 1 and 0. Again 11 plus 11 plus 10, that was only given in the example, that was the same, gives up to 32. Now see, here it is 3, so number of sums required is 3. Here it is 5. Can you see the maximum digit is the result we are getting, because we are taking that number of ones, and according to that number of ones only we are giving the result. I hope this is fine. So what we need to do is we need to check the same. So instead of finding these ones, Deci-Binary, in short they are asking you to find the maximum digit. The maximum digit is the maximum number of sums required, right? Let's see the solution that I have for you guys. Before that, I'll request you to please find at your own. See, what we are doing, we are finding the maximum according to the length we are taking of the digit. Finding the maximum, that's subtracting the ASCII number and the resultant. So whichever is maximum, we'll consider that. This particular approach is actually order of n, where n is the length of the number, because it is traversing it. And once you know the maximum, then obviously you can directly give the result. Now let's have a look at one of the solutions that was there. One of the questions, let me give some basic. 3 7 9 6 8, or a very big number. So what you have to do, you have to check for the maximum. Maximum here is 9, so the result should be 9. Okay, I hope this solution is clear. If there are any queries, please let me know in the comment box. Anything that you couldn't understand, any particular approach, you have a different approach for the same problem, please let me know. Or any particular test case that you feel won't work in this, then please let me know. Thank you, and please keep following. Thank you.